You're watching a Hanford Communities issue briefing, highlighting important environmental cleanup issues at the U.S. Department of Energy's Hanford site in southeastern Washington, issues affecting citizens of the Pacific Northwest and the nation. The Hanford Communities organization was established in 1994 and is comprised of the communities surrounding the Hanford site, forming one voice to advise the Department of Energy on important transition and cleanup issues.
Pacific Northwest National Lab was about $300 million a year in research, mostly supporting the Hanford site. Maybe about 2,400 people, I'm estimating on that. Today it's $1 billion laboratory with about 4,400 people. So it's been a big change from the Hanford-focused mission back in 1991 when I joined to where it's at today. So I'm going to tell a little bit of that story from then to now, and I'm mostly going to focus on the energy and environmental part, which is the part of the lab that I represent. It's about 1,000 people. It does around about $270 million of R&D in a variety of different areas, which I'll highlight. And maybe for our friends from Japan, the interesting part of that story is how we transitioned from a cleanup mission to becoming recognized nationally in a few key research areas that really built off the capabilities that we had in terms of treating the Hanford site. And it was really a workforce shifting. It was shifting our workforce, and a lot of good engineers, scientists, from cleanup to some other applied energy mission. So I think everybody knows the history, but PNNL really grew out of the Manhattan Project. I have about 4 more of these slides normally in the presentation that would walk step by step over those many decades, but this goes all the way back to the beginning in Hanford in 1943, and then the lab being formed, I believe, in as a national lab or national laboratory in the late 80s and early 90s, and our transition over time. I like to remind even my own staff, this is why PNNL exists. We're a DOE mission, and it doesn't matter what administration is running the Department of Energy. We're there to supply research and development around energy, science, innovation, nuclear safety, and security. That's pretty much fundamental. We're an applied mission space and a scientific innovation space. And we bridge that science to the applied areas that maybe a university wouldn't and U.S. industry wouldn't. I love the space. I've been out in industry in my career, and I keep coming back to the national labs because I love that space between fundamental R&D and trying to use that R&D to make a difference in the world. And we're one of many national laboratories. Our sister laboratories, we're an Office of Science laboratory, which is an important distinction. We're not a weapons laboratory like Sandia, Los Alamos, or Livermore. Our colleagues, our peer institutions would be Lawrence Berkeley Lab, Argonne National Lab, Oak Ridge National Lab. And that's who we collaborate with and compete against to get federal funds into Richland, Washington, and into Pacific Northwest National Lab. And the national labs have, one thing has really changed over my time is back, when the Cold War ended and there was the cleanup mission changed and it became privatized like it should have, there was a real question of what do these national labs do for our country and should they exist or not? And I lived through that, should they exist or not? And I say this in a joking way, I think there's been 50 independent studies of the national labs in 40 years. And so we've gotten a little bit of scrutiny on what role we play in that ecosystem, and this is usually by heads of industry and heads of major universities, and this is what they come up with. The national labs are vital as an institution and a collection of institutions to our country to solve big mission-driven problems, high risk, potentially high reward, and that also includes classified work and radiological work, large, long-term, multidisciplinary research, maintain capabilities and facilities for DOE's mission and the S&T community as a whole. And then the part that I really like, and it has changed over the last 15 years in a really positive way, is all these taxpayer dollars, I'm a taxpayer, that come into these research institutions. How does that enable U.S. companies to be competitive in the world market, whatever field we might be in, and along with international collaboration with other industry partners around the world? So I thought I'd just show a little bit of the energy landscape. Here's the kind of history, if you haven't seen this in a while, of the United States energy use over time. And most notably, you can see as we go back 100 years, we were a very different country 100 years ago than we are today. If I think about my grandparents who grew up on a farm in Ohio and worked in 2 factory jobs. And you can see the rapid change as petroleum infrastructure grew, the coal infrastructure grew, and you can see now, and the nuclear infrastructure grew after World War II. You can see now in the last 10 years, we're going through some dramatic changes from a primary fuel use in electricity, where natural gas has really taken off. And by the way, that started back in 2007, 2008. And many of the people on my advisory board, for example, from the Southern Company, knew this was coming over 10, 15 years ago, and they were preparing for it. Coal has dropped off, natural gas is taken off, petroleum is about flat. Of course, nuclear is flat. Biomass has grown considerably, and that's mostly ethanol and fuel. Was where the biomass has grown. And then other renewables and hydro really still, despite all the conversation, are pretty small. And renewables can be, on an average, pretty small, but in certain parts of the country, they're becoming pretty big. And they're becoming pretty cheap. In many parts of the country, solar with energy storage on a market basis is outcompeting natural gas. It's pretty amazing in parts of the Midwest and the West. Here's our exports, and the only reason I want to show this is we're, as a country, becoming a country that's exporting energy. I was just reading the latest 2050 projections, and we will be an exporting country for the foreseeable future. The one thing that's always interesting about these kind of projections, they're always wrong. So they're never exactly right if you look at them historically. So something will change at some point in time, but we will be exporters. In large part, that's because we are a very energy efficient country. And it's not by mandates or regulations. U.S. industry is incredibly energy efficient. Energy efficiency is about the 2.5 cents a kilowatt hour, about the cheapest way to deploy and offset rising costs. I like to show our consumption. Here's our consumption in total energy, and you can see the breakdown by the different primary fuel sources. But as a country, even though our economy is expanding, its consumption's been pretty flat, which is pretty amazing. And then if you look at generation over the last 18 years, we've had some growth in generation, but again, it's pretty flat given the expanding economy we've had over the last 10 years. And this is the one I think is really most interesting if you look at electricity sales. Even though the price has gone up, does everyone realize their prices of electricity have gone up? Our demand has stayed pretty much flat for the last 15 or 18 years. Prices have gone up, I think, over 50% in that same time period, but electricity generation is flat. That is really tough for utilities if they're not moving more electrons over the given assets they have, to be able to recover on that. And then I have 2 slides about the rate of change of technology. I really like this slide. It really makes me think, but if you go back to the 1900s and look at how long in the US it took the telephone and electricity and cars and radio and refrigerators to change over time, it was a multi-decadal process. Usually because some big infrastructure had to be built up around it, whether it was the electric grid or the transportation sector. Now if you look at the rate of change, when you start to get to cell phones, internet, digital cameras, social media, smartphones, it's about a decadal long rate of change. So we always talk about how things are changing. They're changing quick. And in the energy space, there's going to be digitization of energy is going to rapidly change how we do just about everything going forward. And why that's important, the one thing that has just been amazing to me is that we all lived through, and this is a little bit hard to see, this is kind of the projected growth of lithium-ion batteries in various markets. This is consumer, this is electric vehicle, and this is stationary energy source. I think it's always a fun thing. Go home and pull out every battery you have in anything at home, and you'll probably fill up, this whole table of different types of batteries. I was over with DOE in China last October, went to a big battery conference with all the major automotive manufacturers. They're all predicting a possible tipping point in the next decade, the 20s, of the internal combustion engine being more expensive than lithium-ion batteries for cars. So it takes about 15 or 20 years to turn the vehicle fleet over, but think about if in 20 years or 30 years, most of our cars are plug-ins at home or plug-ins where we go to work. It'll fundamentally change everything we do. I went to the CATL lithium-ion battery manufacturing plant in Ningdu, China with DOE. It's about 11.8 gigawatt hours of batteries, biggest battery manufacturing facility in the world, and it was amazing. It fundamentally changed me as I saw the size of this thing, the small 18650 batteries rolling off, and what was coming off the back of this production plant was a package about this big, about these 2 tables, and it was for BMW to go put in their cars, and that was the BMW battery packs going forward. So a big bet's going on electric vehicles. It'll change everything for us, and it'll change the electric infrastructure considerably as well. So as a national laboratory, we really focus on scientific discovery, energy resilience, national security, and at the heart of what we do is really chemistry, earth sciences, and data analytics, with a focus on electric grid modernization, energy storage, cybersecurity, and non-proliferation. That's our focus. Here's a PNNL at a glance today, about 4,400 people. About 60-some-odd% of our budget is the Department of Energy. We're a very diverse laboratory, Department of Homeland Security, various Department of Defense programs, Nuclear Regulatory Commission, and then the little blue sliver is private industry coming in. As national labs go, this is a very diverse portfolio. I really like it. We have about 17% that is really fundamental core science-based, but we leverage that out to a whole bunch of different applied areas across the world and across the country. In the energy and environmental space, here's the key areas we focus on: grid and electric infrastructure. I humbly say we're probably the best laboratory in the country that looks at grid security, both from a cyber perspective, real-time grid operations, where we pull in real-time data from phaser measurement units that are put in on the transmission infrastructure from around the country. We use high-performance computing, data analytics, advanced mathematics to figure out how to take that data in and turn it around and give it back out to utilities in real time so they can operate the grid more reliably, increase resiliency, and hopefully make it more efficient and more cost-effective. A considerable amount of work in energy efficiency and renewable energy, and this is everything from biomass conversion to lithium-ion batteries for vehicles to lightweighting vehicles to building efficiency. Over 74% of all electricity ends up in buildings. There's a great opportunity to make buildings more efficient, smart, put smart technologies into them where they could talk to the grid and provide grid services while saving energy. The big rooftop units on every building that you see the Walmart out Queensgate. If you just had a variable speed motor on that was linked to the temperature throughout the building. We've done studies in 8 different climate zones. You could save, on average, it's like 54% of the energy that goes to that HVAC system. That's 15% of the building's total energy. That's real money when you start to look at the cost of increase of electricity. We're lucky here because electricity is still the cheapest in the country, but it's going up. And in other places in the country, you can save millions of dollars in demand charges if you can balance that energy out in real time. And the technology's coming that you can do that. This is our EM work, where we still do about $40 to $50 million in research supporting ORP, RL, and I think almost every contractor out at the site in some way, shape, or form. And I'll tell you, we are really proud of that. It's our own backyard. We often say we're the continuity. We have scientists who have spent 40 years understanding tank chemistry, understanding many of the important challenges on glass and grout, and we're going to maintain that. And the laboratory, for those in the community here, about 10 years ago, our lab director and a few of us, they made a commitment: we will not lose our nuclear capabilities. 40% of the work we do in some way, shape, or form is supported by those nuclear capabilities in that building out there, 324, if you know the Hanford site, and the 318 building, and a couple others. Those are billion-dollar assets that we've been fortunately able to put a lot of money in to get them back up to standards and put a lot of new equipment in there. And I've now traveled every national lab to look at the infrastructure they have in place, and we're as good as any. Our only challenge is we got to get the word out, of the capabilities that exist here versus some other places, and we're working on that. Then we still do a considerable amount of work on nuclear energy, and that's life extension of existing reactors, accident-tolerant fuels, and a variety of support. And Mark, by the way, I got to point out, Mark Triplett leads so many of our activities, on this side of the house. And thank you, Mark. You will never be allowed to retire from PNNL. Request denied if it should ever come in. But we also support a lot of DOE's nuclear energy work across the complex. And we also support the Nuclear Regulatory Commission and life extension of existing reactors. We were the ones who did the environmental impact statement for Vogtle. Very proud of that, and support a lot of different other reactors, life extension around the country. And then I noticed that some people clean fossil energy is words that should never go together, but fossil energy use is still on the rise around the world, and coal use is still increasing. And what that picture shows is an example where you can take CO2 and use technologies to capture it out of the back of a coal plant. We worked on this with U.S. industry. It was a U.S. industry-led project. Capture that CO2, pressurize it, and put it in the ground. And what we demonstrated here is if you can put it in the ground here with our basalts, it will actually crystallize and become solid. It won't become a gas. In other parts of the country, they're looking at putting it 9,000 to 12,000 feet down below cap rock. And we have the capacity in the country to do it. So I just wanted to show a few things. This is going to go really quick. I just think are cool things we do. So this is our electricity infrastructure operations center. If you haven't been there, please, we'd love to have you come and see that. It's kind of a state-of-the-art facility where we pull data in from utilities, can use data analytics, high-performance computing, and figure out cool things to do with it. This one is a contingency analysis that's now been deployed out to ERCOT and a few others, where we do, because of high-performance computing, we analyze their entire electricity infrastructure and do what-if scenarios. You know, if this transmission line went out, if this substation went out, what are the cascading events? And then more importantly, what would you do about it in real time? And so that's a software platform that's been pushed out to one of the biggest utilities in the country. In the energy storage space, we've made a really strong push to be leaders in grid energy storage, and we have become that now. And there's a hope that we'll get a new building built here in the next 3 years that would support and consolidate all of our energy storage work. But you can see from a bunch of different metrics we have, it's now up to 11 top 1 highly researchers in the world supporting this, which is a large number, a lot of patents going out the door. We won a national program in a $10 million a year battery 500. By the way, this is what a normal battery cell looks like. It's called an 18650. I should have brought a couple. They're about that big, about that wide. And you take about 7,000 something, 400 of them, and you have Tesla's car. So that's what they've done, is they bought the current battery that was available, made by Panasonic and others, put it into modules, put it into stacks, and that's the primary battery that goes into most of Tesla's car. And then 10 years ago, we were completely unknown. This is citations. And now our comparator group is usually other national labs. We're one of the strongest national labs in publications, which in our business is a key metric. We have to show we show up in the scientific literature to be relevant. We've developed fire retardant batteries that are being used and developed for the next generation of lithium-ion batteries. We've taken, with a company called Lanzatech, and taken CO2 from, I think it was a steel plant, with their catalyst, converted that, our catalyst and their technology converted that CO2 to jet fuel, aviation fuel. That aviation fuel went through the entire process of becoming an ASTM standard fuel that could be used in jet engine, which is a really big deal just to make it through that whole process. And then with them, we produced about 3,000 gallons, and that flew on a flight with Richard Branson. Although I'm not sure he was on the flight. He was there to watch the flight go off. I'm not sure he was on that plane. It's unclear to me. And plane flew from Orlando to London to demonstrate the properties of that fuel. We developed LiDAR buoys, which are for a lot of offshore wind and other technologies. We developed that buoy. It's about half the size of this room. Looks kind of small there, but it goes out and makes all kinds of measurements out in the ocean and trying to understand kind of the wind profile about 150 meters up in the air. We make the little fish tags. When we talk about juvenile salmon survivability, the big issue with salmon through our dam system here is the juvenile salmon that go over, around, or through the turbine blades in the dam. We make that little battery based on our battery technology, or has a little transmitter. And in the big years with the Army of Corps of Engineers, we might tag 50,000 fish with this little battery and then track their survivability with buoys as they move down the Columbia River system. It's amazing work. It's about a 93 to 96% survivability rate the juvenile salmon have going through the dam system. We work with TARDEC, the military, on some really interesting friction stir welding technologies where you can take two metals, basically think of a drill bit going to into that middle, but it's not cutting away at the metal. It's actually diffusing the metal into each other, not melting it, diffusing it, so you can take two metals and get them to be perfectly joined together. We've got big equipment, about again half the size of this room, and a lot of industry partners interested in this new technology. That's for armor. And we support the Hanford site, both with the software tools that we've developed over the years with our partners to look at various cleanup missions. Demonstrated the vitrification of 3 gallons of Hanford waste in our RPL building about a year ago. For us, that was a big deal because it verified every step in the process at a smaller scale. And I'm very proud, because of where we're located, it's very easy for us to get radioactive waste up to that building because it's still on the Hanford site. This one I'm especially proud of as well. That's a cask arriving at PNNL roughly a year ago from North Anna. It was sister rods. It was high burn rate fuel, and the DOE accepted that fuel. And the question was, if you have high burn rate fuel now sitting and not going to a final repository, are the properties of the cladding and the core changing over time? So if you start to move it in 15 or 20 years, is it going to maintain its integrity? So despite the size of that tank going into our hot cell, it's a very small research quantities, just about 10 pins, in a certain number of length, and we pull them into the hot cell, cut them, sample the gas, and then go do integrity testing on the cladding. As I mentioned, it's so important to keep the existing nuclear fleet in this country relevant. It will go away by 2050. It's the current plan. If the licenses continue to slow down, I think we've gone from 104, I think we're at 98-ish right now, and there's a good 10 or 15 more that are going to shutter, and that's a big part of our base load. We work on the stress, corrosion, cracking of aging of the electric cables and other risk assessments. And then I wanted to point out this slide. I'm not going to walk through this, but we're a competitive research organization. We have to write proposals. And Washington State, and especially the Clean Energy Fund, has been really important for us in many key areas. Anytime we can show leveraged investments with the federal government dollars, we're more competitive. And in almost every one of these cases, not only can we show leverage investments with the Washington State Clean Energy Fund, we show industry partners who are committed to it as well. And so we've had a lot of battery demonstrations, for example, with Avista, Snohomish PUD, and others, where they want to test the battery. We get all the data in and help them optimize the use of energy storage devices or smart buildings technology. So it's been a really good partnership for us. I believe in this space we've grown about $70 million over the last 4 years of new federal funding. And I think in large part that's been enabled by the state funding, this partnership. There's always if you look at national labs, there's a partnership of the state, the federal government, and the national lab to become well recognized in key areas. And those places that get that recipe right become the places that tend to do really well, and then tend to build national reputations and become critical mass, and funding follows that. So we've been very successful. For our local representatives here, that's what that translates to is we've hired about 200 people in the last 2 years in this mission space. Here, good jobs and all the things that go with that. And that's it. That's a very high-level, quick overview, and I didn't get to touch on everything or talk about all the fun stuff we work with in all our partnerships. But any questions?
Else perspective of how that can be without a regulatory environment that forces it.
Yeah, I don't know the exact answer, and of course I have to be careful, so those are like a general average. If you look at national averages on electricity prices, my gut intuition though tells me that it's starting to be more of constraints and capacity limitations, and so you're starting to see more congestion and constraints during the peak hours of the day. And so, there'll come a time where, usually the grid is not running at full capacity all the time, but those periods where in the middle of summer or the middle of winter or when we all go home at night or when we all turn our air conditioner on in the middle of a hot day, those are the periods that are starting to drive the costs up.
Yeah, I look at that and I look at it, maybe that's the battery storage aspect of it, right? You can store the energy not through your peak periods and then draw from those batteries during your peak periods.
Yeah.
Is that kind of the global plan, I guess, the best way to look at it?
Yeah, I think that's the idea that I think would make the most sense, and batteries will have to be dirt cheap to do that. you know, because there's just not a big enough price differential. Certainly here, a few cents kilowatt hour isn't going to cut it. And places like Hawaii, where you're maybe at 36 cents a kilowatt hour, it absolutely makes sense. You and I, it makes sense to put PV if we were paying 36 cents a kilowatt hour, you know, on our roof. But it's very hard to swing, you know, megawatts or gigawatts of power. It's hard to store that right now. It's probably not cost effective, and it's very hard to shift that. So I actually see maybe a view of the world where energy storage is deployed, you know, behind the meter, at a building, at your house, at a substation. And if we really do get to the point where there's big renewable energy, then and energy storage gets cheap enough, which to me is at least a factor of 10 below where it's at today, I think you might then start to have that big shift. But I think the price increases are, you start to become capacity limited, certain T&D infrastructures become constrained, and then it's demand charges. So a lot of places, a big part of their bill is the demand charges. I know at ours it is.
Has PNNL seen new technologies in how we do D&D, or are we just seeing reapplications of older technologies?
I would say those are new technologies being brought to the contractors to help them, whether it's the dispersion modeling or whether it's subsurface modeling. We're bringing those state-of-the-art tools to support those missions. And it's making a big difference. What's changed in the last 25 years, certainly in my professional career, is really the modeling and the computational horsepower. And most of you look like you're of the same vintage, you know, and you can remember when we were 25 or 30, we didn't have anywhere near the tools that we have today. The other thing that's changed is our ability through unique characterization tools, you know, microscopes and other things that let us see now down at the atom level in real time. So we can start to, I always joke, 25 years ago when people wanted to understand what was going on in materials, it was cartoon pictures. We all drew because we had no ability to see what was actually going on. Now we see it, and now we're able to model it. So the tools have gotten so much better. Everything from the tools to predict fate and transport of a species in the soil, you know, and understand how that's going to react with different soil species, how the plumes might migrate, and then most importantly, the transparency to visualize it and share that information with others. I was just reading some mega trends for energy, and this is one I really believe in. We're going to have more data than in everything than we know what to do with, and that's happening right now. And you see it you're seeing it right now. It's being used on all of us to predict what we're going to buy at the store next. You know, you go Google one thing, and all of a sudden you got ads hitting that. Well, that's an easier one to pull trends out of that kind of data. We're talking about trying to understand kind of the fundamental phenomena that are going on, and that data, it's going to just change how we do research, and I hope it'll change how that research moves out into the world.
The technology that PNNL, I believe, was involved in, and the detection at borders, what section of PNNL is involved in that?
Yeah, you know, I didn't have a chance to go into that, but about half of our work is national security work on the non-proliferation side. And a lot of my staff actually support a lot of that work. And it came out of that national security, the NNSA side of the house. And that's the radiation portal monitoring work, you know, where we have helped deployed for the Department of Homeland Security, I believe at every sea and land entry point in the country. It's a little device that looks like this, and cargo goes through it, and it's looking for residual signatures. Yeah, very proud of that. The other one that came out of PNNL was, you know, from an old DOD project many years ago, was the PNNL. They say the PNNL salute at the airport when you stand there like that, and the millimeter wave sensor device goes around. That came out of PNNL as well. I always say you're welcome, you know, for that one. People don't seem to like that one as much.
To find out how you can become more involved in this important regional issue, or to have a Hanford Communities speaker talk to your organization, contact the Hanford Communities at 509-942-7348 or visit our website